Good evening and welcome to the Ask and Learn Geothermal Educational Webinar Series. This webinar is on geothermal, a league of its own, and this will focus on how geothermal compares to other types of heating and cooling systems brought to you and presented by GeoComfort Geothermal Systems. As far as an introduction this evening, my name is Tim Wright, and I will act as your moderator. I do work for Enertech Global, and I also want to welcome Jeremy Lang.
Thank you, Tim. It's great to be here.
GeoComfort systems are built by Enertech Global, and we have been in the geothermal heating and cooling business, manufacturing-wise, for about 20 years. All of our models are manufactured in Mitchell, South Dakota, and our corporate office is located in Greenville, Illinois. Our products are sold throughout the United States and Canada, and we manufacture both residential and commercial products, and obviously our focus is on quality and always striving to do a better job for our customers. To make the most out of this webinar this evening, please feel free to take any notes that you would like, as well as ask a question. And as you'll see, a little box will be over on your right-hand side where you'll have an area located near the green arrow that allows you to go ahead and type a question. And you can submit that question, and at the end, when Jeremy's doing a wrap-up, we'll be more than happy to answer your questions. The other thing that we offer to you, obviously, would be to research and review anything about GeoComfort systems, as well as an Enertech made product.
Thank you, Tim. I'd like to start out with a little bit of information about geothermal. A lot of people think that geothermal is something that's new, but it's not. It is as old as dirt. As you can see on the screen, we've got a copy of Life magazine. At the bottom, you'll notice the date, October 25th in 1948. In that magazine, there was an article featuring the fireless furnace. In this article, we can see that all the system does is pumps heat from the earth to the house and back. If we take a look at the system components, in the illustration here, all of the components that exist there are the same components that we use today with more modern technology and reliable components. So let's take a look at the geothermal system. What we have is a geothermal unit. We have some pumps to circulate fluid to and from the machine between the ground loop. We also have the ground loop heat exchanger. So we're going to take a look at some ground loop options. One of the options is a pond loop, a horizontal loop, and a vertical loop. Each one of these different applications has its different benefits, and your project would be, I would say, you need to invite a contractor out to take a look at your project to determine which loop field option would be the best for your project.
So Jeremy, would one be any better than another, or is it really more lot specific?
Well, it's actually, as far as the geothermal system is concerned, or the geothermal unit, it doesn't really care what type of ground loop it's connected to, as long as the ground loop is adequately sized and properly installed. So really, the lay of the land is essentially what determines the type of the ground loop. If you have a lot of green space, we could do a horizontal loop. If you live in a more urban area and you have a smaller yard, then we would need to go straight down and do the vertical ground loop.
Jeremy, before we go on, one more question for the audience.
Yes, sir.
With regards to showing those pictures in the geothermal heating and cooling system, obviously there was no outdoor unit there.
Absolutely, Tim. So your central air conditioner now would sit outside in the flower bed and absorb heat from the house and reject the heat outside. With the geothermal system, we use the ground loop. So our outdoor section is actually buried beneath the grass, and there's no noisy outdoor unit or gas meter or propane tank because we run on electricity. We don't use any fossil fuels or waste any energy. We use a little bit of electrical energy and harvest energy from the earth. So let's take a look. Let's dig a little deeper. A geothermal system operates in many ways much like a refrigerator. When you put something warm into the refrigerator, it turns on, absorbs the heat from the air, takes it into the compressor using refrigerant, and then discharges that heat out over the back of the refrigerator and into your home. Now let's spin that and take a look at how a geothermal system compares. In the air conditioning mode or the cooling mode, what we have is a fan. We have the fan pulls the warm air from the house across the cold air coil. The cold air coil absorbs the heat, giving you cool air to blow out through the registers. Now that heat is taken through the compressor and out to two liquid-cooled heat exchangers. The compressor raises the pressure and temperature of the refrigerant so that we can discharge to the preheat tank for your water so you could shower or do dishes or laundry with the heat that your central air conditioner normally throws away. So we're essentially recycling the heat from in your home into the water heater. Once we get the tank up to temp, the remainder of the heat goes out into the ground loop heat exchanger.
So again, for the audience, Jeremy, so as we're air conditioning the home, it'll also heat and cool or heat your hot water.
Absolutely, Tim. So it's really one popular thing for consumers. They really enjoy the idea of absorbing that heat from the house, recycling it, and not wasting the energy. So it's pretty neat. So now we're going to take a look at the same system, but we're going to change modes. We're going to look at the heating mode. The fan will pull cool air from the house across the warm air coil, warming the air up and discharging air out through the registers in the home. All of the same components are used. We simply reverse the machine so that we can put heat into the house instead of taking it out. And in this mode, we also share some of the energy that we absorb from the earth with the preheat tank. So in both modes, the geothermal system is always going to be preheating your water every time it's operating. So what we're going to do here is just compare some costs. The most effective way to do this is just to take a look at the cost per million BTUs. So if you have 1 million candles lit, that's how much heat we're going to be taking a look at here. What we'll look at is the comparison of a geothermal system, natural gas, and propane. And we're going to take a look at some different rates. And the first one we're going to look at is 5 cents a kilowatt. If you have a 4-ton geothermal system, which is the average system for today's modern home, if you buy electricity at 5 cents a kilowatt, you would only have to pay $3.76 for 1 million BTUs of heat energy. If your electrical rate is 10 cents a kilowatt, then you'd be paying $7.51 for that same million BTUs. Let's look at how fossil fuel compares. If your fossil fuel is coming to you at $1 a therm for natural gas or $1 a gallon for propane, these are the prices that you'd have to pay. And that's with a 98% efficient furnace. That's the most efficient fossil fuel furnace that you could purchase today. Let's take a look at propane at a realistic price. $2 a gallon would cost you $22.28 for that same million BTUs of heat. So you can see, if you're a customer that's burning propane, there's a pretty significant savings available if you would invest in a geothermal system. So what does all that mean? To sum it up, you'd have to buy LP or propane for just about 1/4 to even come close to the cost of what a geothermal system can do. And you just can't get that kind of deal anymore. I'd like to thank you for joining us tonight, and we're going to take a look at some questions as I hand it back over to Tim.
Yeah, Jeremy, thank you for sharing that. But just with regards to a few of the questions that have been asked this evening, let's hit the first one, and you can jump on this one, Jeremy.
Okay.
Can a geothermal system provide radiant heat?
Absolutely. We took a look here at a forced air geothermal system tonight. The system that we saw in the illustrations would use ductwork. Could be a new home with new ductwork, or could be an existing home with existing ductwork. Now, another popular option is in-floor radiant heat. It's one of the most comfortable ways to heat your home. With a radiant heating system, what we do is bury tubing in the concrete, and we circulate warm fluid through the floor until the thermostat gets warm enough. So we're providing all of the heat from your feet.
Very good, Jeremy. Okay, a question just came through. How long to pay back on the added or the increased investment?
That's a great question. It depends on the existing utility company there. So, are you burning natural gas? Are you burning propane? Are you using electric heat at this point? So, typically, a propane customer, we would see a payback in somewhere in the range of 5 years. A natural gas customer, it sometimes is out to 10 years. Um, One of the most important things to remember is that a geothermal system gets 75% of the energy that you need from the backyard. So when you don't have to purchase as much fossil fuel and burn it and waste some out the chimney, you can reduce your home's electrical demands or your home's energy demands by harvesting that energy from the earth.
Very good, Jeremy. Here's another side of that question is if it's a new construction, talk to me about that. Rolling that into the mortgage. How does that look from a return on investment?
Oh, absolutely, Tim. So if you're building a new home and you take that upfront added investment. So you're going to build a new home, you're going to need a heating and cooling system, you're going to need a water heating system. So how much more does it cost me to upgrade to geothermal? So that difference
Incrementally?
Incrementally is did we lose audio? Oh, we're good. Okay. So when you basically, if you're building a new home and you upgrade to a geothermal system, it probably costs you $20 or $30 a month added onto the mortgage. And we can save you more than that a month. So your positive cash flow right out of the gate if you're building a new home.
So that return on investment then is immediate for new construction.
Absolutely, yeah. You can save money on utilities in your existing home, and basically you're saving more every month than your mortgage would increase.
Great explanation, Jeremy. One more here for you as well. Can a geothermal system be ran on a well?
Absolutely. That's what we call an open loop geothermal system. And one of the things to consider is the amount of water and also the quality of water that's available. An average open loop geothermal system could consume anywhere from 2 to 2.5 million gallons of water every year. Now keep in mind, the closed loop geothermal systems that we showed you today are filled with water and antifreeze on the installation, and that fluid recirculates for year after year. The open loop system harvests water from the earth, absorbs the heat from it, and discharges the heat. So I think we lost a little bit of audio there. So we're going to talk about the open loop system. The water in the ground is 50 degrees. The pump would turn on. We'd feed the water to the geothermal system, take the heat out of the water. If we're in the heating mode, give the heat to the house. Or if we're in the air conditioning mode, we would reject the heat into the water. But you'd have to have a stream or some place like a pond to discharge that water because there's quite a bit coming out of an open loop geothermal system.
But Jeremy, I think it's also fair to share with our audience that the gallons per minute per ton, not only is it a lot of water, but we have to have very good quality,
Yes,
and
sir.
we have to have obviously the quantity.
Absolutely. Yeah. So a well driller actually would typically know how much water your well can provide. So what we'd want you to do is contact us. We get a hold of a local representative that's in your area experienced with geothermal and our products, and we get them introduced to your project, introduced to you, and they can take a look and see how they can help you.
Excellent question just came across the webinar. What is the largest or biggest barrier to technology implementation?
Consumer education, which is why we're doing what we're doing today. A lot of people think that geothermal is expensive. It's actually more expensive to not have geothermal. If you don't install a geothermal system in your house, you're going to buy it anyways. You're going to get a few years down the road and you've paid the utility company enough money to purchase a geothermal system. If you would have done it in the beginning, the system would have been paid off very quickly.
So once we get the customers, the audience, the general public more in knowledge or more facts,
Yep.
Are you finding that many people really take a hard look at geothermal?
Absolutely.
Obviously, more so for the economics, but why else would they go geothermal, Jeremy?
Well, comfort. One of the things that I always hear from homeowners after they install a geothermal system, and also experienced myself, is that My house is more comfortable from level to level and from room to room. The temperatures are more evenly blended, so I don't have the hot and cold spots that I used to have with my gas furnace.
Very good. Excellent explanation, Jeremy.
Another benefit, Tim, would be no fossil fuels, no risk of carbon monoxide. We use electricity. We actually leverage electrical input energy to harvest the heat from the earth. So when you feed the geothermal system $1, what we do is we operate a few components, go down into the ground, and we'll bring you $3 to $5 of heat energy through the geothermal system. So for $1, we'll deliver anywhere from $3 to $5 through your ductwork or into your radiant inflow.
So obviously that would be based on, Jeremy, whether you're going to do a forced air system or whether you're going to do a water to water. There's your variable.
Absolutely, yeah. And so if a consumer is interested in taking a look at a radiant inflow project, the best thing to do is to get one of our contractors involved on the front side and help them, have them help you plan your project, because their experience is critical to your project's success. It's really important to have a contractor that knows what they're doing and is very experienced with geothermal. It's not very complex as long as you have good fundamentals in heating and air conditioning. And what we find is that with our contractors coming to all of our training, being educated by the factory, essentially makes them sharper, or the sharpest tool in the shed, if you will.
Jeremy, if you can, touch one more time on that cost per million BTUs. We had propane, we had natural gas, we had electricity. All of those are obviously rated differently or calculated differently. So is that really the cost per million BTUs, the common denominator to levelize the playing field?
Yeah, it is, Tim. So if you're looking at a fossil fuel furnace, it's rated in AFUE. If you're looking at a geothermal system, it's rated in COP. If you're looking at an air source heat pump, it's rated in HSPF. All of these things are different rating scales which produce different numbers, and it's pretty confusing for the average homeowner. So when you're looking at the work the appliance does, which is produce heat, we need to take a look at 1 million BTUs of energy and how much it costs to deliver that. So as you saw on the slide, the geothermal system is the most effective way, the least expensive way to get that heat, which we all know we need. In weather like this, it's important.
Excellent, Jeremy. One last question. Again, coming in through the webinar here. And how about warranty? Can you address that?
I love this question. You know, our GeoComfort systems have the best warranty in the industry. We are the only manufacturer that offers a lifetime compressor as well as a lifetime air coil warranty. So our standard warranty comes 10 years parts and labor for all of our components, our machine, our pumps, our thermostat. If you decide to do a zoning system, which would mean you'd have a different thermostat on each level, we also cover the zoning electronics, the zoning motorized dampers, as well as each thermostat under our 10-year parts and labor warranty. But the big differentiator, again, is that lifetime warranty. The original purchaser gets to have a lifetime warranty on the compressor and the air coil, which is essentially the heart and the heat exchanger of our system, the most important components.
So even after that warranty period with the limited lifetime that you've described, that's one compressor, or that is one air coil part only, out to the customer for free.
Absolutely. And it's a limited lifetime warranty because it's limited to the original purchaser. If the house gets passed down for generations, we obviously, or sold, we obviously wouldn't extend that limited lifetime warranty to the new owner. But the original purchaser can carry that warranty.
Jeremy, I think from our experience, we can say that many folks who put in geothermal, they love it, they're comfortable, and they just don't move.
Absolutely, yeah. I guess the only downside to geothermal is that if you decide to move, you can't take your loops with you.
Very good. That's awesome. Okay, so as we wrap up, please jump on your computer as you are right now, or write this down, www.geocomfort.com, to use our savings tool or calculator, or also to find a dealer in your area. And questions about your home or any upcoming project, please contact us at 618-664-9010 or ask&learn at enertechgeo, that's geo.com, if we can help you in any way. Watch for this webinar again at www.youtube.com/EntertechMFG. It stands for manufacturing. And then you can replay this at any time. Join us again, please, for another upcoming webinar to learn more about, does it work where I live? Man, that's a great question, Jeremy.
Absolutely. You know, a geothermal system essentially works everywhere. We have systems in Alaska. We have system in the Caymans. We have geothermal systems all over. So I'd really like to see some people come back and just take a look at our next presentation and see what we've got to offer.
Fantastic. And that is going to be held next Wednesday, December the 9th at 8:30 Central Time. So please take the time, folks, and join us.
Thank you.
That wraps it up. Thank you very much.